This is Geometry 5.2. We're working on finding the measurements of angles, particularly with regular polygons. A regular polygon has all congruent sides and congruent angles. So it's a polygon with all equal angles. One very common one would be a triangle that has all equal sides and all equal angles. If you take 180, because that's what every triangle adds up to equal, and divide that by 3, then we would get 60 for every angle. This would be a regular polygon, specifically for triangles. You have another regular polygon, one that you're very familiar with. If all sides are equal and all angles are equal, you know that a four-sided shape has to have 360 degrees inside it. If they were all 90, then that would add up to 360 and all sides the same. So that would be specifically called a square. This would be an equilateral triangle. Those are both examples of a regular polygon. The interior angles, the ones on the inside, and the exterior angle, when you extend the sides, you get to the exterior angle. They're going to form together, they're going to form a straight angle. What do we know about a straight angle? The sum is going to be 180 for a straight angle. They are supplementary. The exterior angle and the interior angle will be supplementary, a straight angle. Okay, to calculate each interior angle of a regular polygon, you need to know the sum of the interior angles. That's n minus 2 times 180. That's all the angles added up together. And if we divide all of those angles equally, then we're going to get each interior angle. So each interior angle is the total sum divided by the number of angles. So for example, if we had 180 degrees, which is a triangle, if it's going to be a regular triangle, then it's going to be 180 divided by 3, because there's 3 angles. 180 divided by 3 is 60. So each interior angle would be 60 degrees. Or if you had a four-sided shape, you know that the sum of the interior angles is 360. Divided by 4, 360 divided by 4 gives us 90. So each interior angle is 90. That's what that represents. Each exterior angle, the angle that's going to be on the outside of a regular polygon, they're all going to be equal to each other also. They're not going to all be 60, of course, because these have to be supplementary. So we could expect if this is 60, then that's going to be 120. If this is 90, the exterior angle is going to be 90, because together it's got to make 180. Each exterior angle of a regular polygon is going to be the sum of all the exterior angles divided by the number of angles. So 360 divided by 3 is 120. Each exterior angle would be 120 degrees. 4 exterior angles divided by 4, well, 4 exterior angles, which is 360, divided by 4 is going to be 90. So different ways to think about it. All right, let's try some word problems here. Each interior angle of a regular hexagon is 120. So if we try to draw a regular hexagon, so there's my attempt to draw a regular hexagon. All the sides would be the same. All the angles are the same. And they're saying that each one is 120 degrees. We should be able to calculate that. Just as an example, we know that n minus 2 times 180, 6 minus 2 times 180 is going to be 4 times 180, which is 720 total. And if we know that there are 6 angles, we divide that amount by 6. Each angle itself is going to be 120. That's what they're trying to talk about. The question is, what is each exterior angle going to be? So what is this exterior angle out here going to be? Well, there's a couple different ways we can think about it. We know that the interior angle plus the exterior angle has to be supplementary, has to add up to a straight angle. So if the interior angle is 120 and we do not know the exterior angle, we can calculate that exterior angle by subtracting our 120 across. So if this was 120, we could figure out the exterior angle by knowing they have to be supplementary. So that's one way to do it. The other way is to understand that every exterior angle, all added up together, these are all exterior angles, 1, 2, 3, 4, 5, and 6 of them, all added up, they're all going to be the same amount, is going to always add up to 360. If we divide that by the number of exterior angles, we're going to also get 60 degrees. So there's two different ways to think about that. If you know you have a hexagon and you're looking for the exterior angle, you can do it by knowing the interior, or you can know it by taking 360 divided by 6. The base of a lamp of a regular nonagon. How many sides is a nonagon? It's 9 sides. Find the measure of each interior angle. A nonagon is a little tricky to draw, so I'll keep us away from that pain. But what is the measure of each interior angle? Well, we know that n minus 2 times 180 divided by n. That was our notes right up here, was each interior angle. That's each interior angle of a regular polygon is going to be n minus 2 times 180. That's the total sum, divided equally by the number of angles, gives us each angle. So if we know that we're working with a 9-sided shape, and we're going to end up dividing that by 9, so 9 minus 2 is 7. 7 times 180 divided by 9. We take 7 times 180. That is 1260 divided by 9. We get 140 degrees. So each interior angle would be 140. what would each exterior angle be? Well, there's two different ways for us to calculate this. We know that the interior angle is 140 degrees. So what is that going to make the exterior angle? Well, we know they're supposed to be supplementary. So 140 plus the exterior angle has to add up to 180. By subtracting the 140, we know the exterior angle is going to be 40 degrees. Or you have another way to do that. You know that 360 divided by n equals each exterior angle of a regular polygon. That came from our notes up here. Each exterior angle, 360 divided by n. So if we know that we have a 9-sided shape, that comes out to be 40 degrees apiece. It doesn't matter which way you do it. Here we're focusing more on the interior angles to figure out the exterior. Here we're more focusing on them all being the same, adding up to 360. So we divide them equally to figure out each angle. So you go ahead, pause the video. You might be able to do this one in your head, but try to show what math is necessary for you to reach the conclusion that you expect for this. Each interior angle of a regular nonagon, we don't know the number of sides. It's one you're very familiar with. Each interior angle of a regular nonagon is 60 degrees. How many sides does this polygon have to have if each interior angle is 60? You probably know the answer. Pause the video, calculate this out, come back, and we'll walk you through it. So we have two ways to talk about this. We could talk about it using the interior angle. Here's our formula for the interior angle. Since they give us 60, that would make sense. N minus 2 times 180 divided by n, that is each interior angle. And if that's going to be 60 degrees, then we can solve for n to figure out what number of sides would make that 60. The first thing you would do is cross multiply, and you would have n minus 2 times 180 equaling 60 times n. Now we have to deal with this 180. So we would most likely want to distribute to get 180n minus 360 equaling 60n. Then when we subtract the 180n, when you subtract that across, we get a negative 120n. And then we divide by the negative 120, and that clearly comes out to be 3 sides. You probably knew it was a 3-sided shape. We talked about it right there, that if each angle is 60 degrees, you're going to have 3 sides to it. Next, we're going to come down to each exterior angle of a regular nonagon is 30 degrees. The exterior angle. So if this is an interior angle, that might happen a whole bunch of times. An exterior angle is out here. If that is 30 degrees, how many sides are we going to have? That's the question. So one way that you can do it, you could treat it as the interior angle is 150 and do all that crazy math. If you really like that algebra, you're welcome to do that. But let's just focus on the exterior angle. The exterior angle is 30. So if you have 360 degrees to be the sum of all the exterior angles, we could divide that by the number of angles to get the sum, or to get each, remember our formula, each exterior angle is 30 degrees. So you cross multiply. That's 360, or no, it's not. It's 30 times n divided by 30 to get the n by itself. And that comes out to be 12. It would be a 12-gon. All right, on the back we have 3 different examples. Let's do these backwards. I don't really like this one up here yet, so let's work these in backwards. One thing that we recognize here is the way that they put these curves in here implies that the angles are the same, but they're clearly not the same. This is 132, this is 122. So that's not a good notation that we're familiar with. So trying to figure out how can we determine this angle, a little problem solving. Well, if this is 112, it would take 68 degrees to get our interior angle. If this is 122, this would take 58 degrees to get our interior. Now we know that this is a 4-sided shape that has these 4 angles, x plus 132 plus 68 plus 58 has to equal 360. So if we add those up, 132, 68, and 58, we get 258. And we can subtract that across. So we take 360 and subtract our 258, and we get 102. So that missing angle has to be 102 degrees. We're going to treat this next one just like it. If we know this is an exterior angle of 58, then the interior angle has to be 180 minus 58. So that's 122. So the 4 angles have to add up to, in this case, again, 360 degrees because it's a quadrilateral. And this last one, it's a little weird because we have these extra amounts, but we can still make this work. This would have to be 112. We have the interior angle. Now what's weird about this one, we could say 180 minus, you have to use parentheses for y plus 48. It's the only way that I recognize how we would do that one. So we would use 112 plus the 2y plus this crazy looking interior angle, and don't forget the 90. You'd have to distribute through. and then I'll let you collect your like terms and divide. But now we've turned it into one long-looking equation, but it has our variables of y. Here's the solution for each one of these. We collected our like terms, collected our y's.
Thank you.
Gives us 26. And then our last question, we collected our like terms, moved it across, and x was 102.